Alright, so we want to talk about wet maps now. This is already quite wet, so we should probably leave a residue wherever this liquid touches to basically better integrate it into the scene. Right now we just have a lot of water kind of flowing over something that could be glass or porcelain because nothing sticks to it. There's no, again, wet sheen left behind. So that's what we want to do with a wet map. We want to scatter points all over the place where the water might go, and if those points touch the liquid sim, they'll say, I'm wet now. Those points then will be read by the shader while rendering, and the shader will say, if I'm next to one of those points, if the area of the ground that I'm shading is near one of those points, then render me differently. Specifically, render me shinier and darker. So that's what we're trying to do. So to do that, let's set up a friggin' wet map. So we'll put a geometry node down, and we'll call it maybe wet map. Wet map cache. Now this is gonna have a source, sim, and cache actually, but honestly, this is a relatively simple enough process that we just can do it all in one node here. So I'm gonna jump in here. We want the wet map to be in terms of the ground, or at least all of the visible parts of the ground. We don't care about all the bottom sides of the rocks and stuff that we can't see. So let us object merge in the collision geometry, and in particular the collision volume. The collision volume is already unioned essentially all of the rocks and ground together so that it's, it's hollow on the inside. So that's a good place to start. This is also represents literally what the water is resting on anyway. So it's a great way to start for a few reasons. So let's convert VDB. Let's turn this into a polygon surface. And again, this represents the closest things that the water can be touching. Now we know the water is never going to get out here. We also don't want to scatter points everywhere. So let's just make a group and just scoop out the area via a bounding region to say I'm interested in. If you lose that, you gotta click that again. I'm interested in these areas, and we'll use a delete node in a second to. Why do I keep losing that? So weird. A lot of weird bugs. Oh, we got another group node. Anyway, so we do that. We do that. We just want to limit. Oh my god. We just want to limit where we will scatter our points onto. So that's good enough. Put a blast down and say let's delete non-selected, that group that we just made. And there it is. Now we want to scatter points, like I said. Hard to say how many we want, but generally speaking, I want to have so many points that I can't really see any space between them. So I'm going to try this and just keep throwing more points at it until it seems like we got it. It might actually, this might be enough. Was that 1,000,000 points? So that's pretty good already. For the sake of argument, I'm going to do 2,000,000 points. Because why not? I guess I'll have to turn off the max points thing here because it's actually limiting it to 1,000,000 points. Max points is good in case you do a density scale kind of thing and you might make more points than you were expecting. All right, so we have it. We've got 2,000,000 points. So it's so dense that it's representing the surface pretty well. Now, it took a moment to actually come up with that many points, so it's a good idea for us to cache that. I'm going to jump into the whitewater cache, grab the file cache thing here that we keep using, throw that here. Now this, a couple things we need to change. For one, we're only going to have it be one frame. We're going to run a sim on top of this, but it will always be these points. So say save current frame, and we're just going to save it that one time. And we'll call it file cache wet map static. So save that, reload it, like so, and we have it. Pretty cool. While we're here, we might as well make the other one a complementary one here. Dynamic. This one will be in terms of the frame range, so you can keep that one as is. So what are we going to do now? We want to actually have an attribute on these points. We'll call it wetness. And the wetness will be wherever we are near the surface of the liquid. So we're going to get that liquid surface. You'll remember from before that we had the two caches for this reason. So now's the time to do this. Actually, we also needed this for the whitewater, so multiple reasons why we had to do that. So in any case, we have it now. It's the sign distance function that we were interested in, aka the surface volume. So I'm going to blast away the surface, or rather keep it. There you go. So as you recall, the volume stores the distance to the surface. Now the surface is never going to be literally intersecting this, because this is the ground that the liquid is resting on. So instead of saying, instead of sampling the volume and saying when am I inside of it, we need to say when am I close enough to it that we are essentially inside of it. So I'm going to say our new wetness attribute is going to be a sample of that volume, which is the 1th input, aka the 2nd input, the 0th primitive, which is the only one, in position P, which is, where the current point we're iterating on. So that's going to get us the distance. So we're not done yet, but let's just start there. So if we look at those values, we can see they go from apparently about 0.1 to negative 0.04. Now, these points should theoretically extend much further away from the surface of the liquid than that. But recall that this is a VDB. It's only storing those values within the band, the narrow band around the surface. But that's fine. We don't really care if we're that far away anyway. So how far should we care? Let's say you are wet if you are less than some threshold amount away. So if we were to say maybe 0.1 or something, let's visualize that instead. Let's click wetness, and let's see what we can get. Oh, it's not actually on. So it seems that maybe everything is that. Let's see what our wetness value is. So wetness is 1 apparently. So what if we went down to 0, 1? All of a sudden we've got something. So apparently at 0.1 everything was closer than that. And again, probably because the values never really got that high anyway, as we saw. So 0.01 actually already looks pretty good. If we wanted a more exact number, but instead of just guessing at it, if we look at our liquid sim parameters, or really if we just look at our regular controls here, the voxel size is 0.02 and the particle separation is 0.01. This is essentially how far away the particles ever are from anything else. This is how far the particles are from each other, and it's how far they are from whatever they're resting on. So this number, which we kind of stumbled on by chance, is the right number to use. I hope that makes sense, because the particles are never going to get any closer than that. If we, or some of them might, but if we were to say, oh my god, what is going on with Houdini today? If we were to say 0 here, you can see we have these pockets all over the place of it saying, oh, I'm not wet, I'm not actually touching the water. And that's just because of I would say, it's not technically numerical error, but it is, oh look at that, I broke all the stuff over there. It is nonetheless wrong. So copy that over there like we did, and we got it, and there you go. Now if we scrub on any frame, we can see that that is so. Now this is not really that helpful because that tells us that this area is underwater, but this doesn't last from frame to frame. I don't get to see that after the water passes by, like after this wave recedes here, I want to see that this is still wet, that information, much like a simulation, needs to persist over multiple frames, as opposed to the way SOPs generally work, which is that they evaluate the whole network on every frame.